Well, we do use satellite here every day, and a little bit later I'm going to show you something a little bit different. We're going to go through a tour of the different channels available on GOES. There's 16 basic channels and some multispectral channels, so you'll want to stick around for that. Right now we've got this squall line rolling through the Ohio River Valley down into Texas, and with that some severe weather. In the wake of that, cold air advection, so getting a little bit of winter back into parts of the U.S. And up north, they've got the warm air advection. There's not much warm air at the surface up to the north, but down around upstate New York, it is coming up into the 70s. And a fairly nice day out west, so let's head to that surface map. Here's one little map I have. It's a composite of temperature and frontal positions. We can see those 70s up into the Buffalo area. Very strange after that brutal winter we had just a few months ago. And even 80s around Charleston, West Virginia. Lots of 70s up in the Great Lakes area, and in the Dakotas back down into the 20s once again. There's the full surface map this afternoon. You can see exactly where that warm sector is. It's not here along the squall line, it's up in Michigan. See that 70-degree reading there with a dew point of 55. So that's definitely part of that tropical air, and you can see on either side of it much colder, 30s up in Ontario and 20s and 30s in Iowa. So that is the warm sector making its way up into Michigan, and some of that also in New York. And that gives us the location of the warm front. Prefrontal squall line through Ohio down into Kentucky and all the way down into Louisiana. And as we mentioned, a nice day out west. 1024 millibar high across the Great Basin area, and a small area of troughing around Santa Fe and Albuquerque. Heading out west into the Pacific, it looks fairly quiet, but one little weather system off of British Columbia. We'll check the model graphics for that. And some cold weather returning to parts of Alaska down below zero in the Brooks Range and North Slope, but in the interior, 20s and 30s, which I think is about normal for this time of year. In northern Canada, sub-zero conditions. We don't have those really cold minus 20s and minus 30s. However, pretty much everything north of this line is below zero. And back into Canada, kind of a nice day there in the prairies, warming up to the 30s, but a strong weather system there in Ontario that will be moving into Quebec later this evening. A quick check of watches and warnings. Well, we've got a blizzard warning for North Dakota. That's on the back end of that system in the Great Lakes. Got that cold air advection coming back in, and the wraparound, the cold conveyor belt, helping to feed that region, but it will gradually start improving. Severe thunderstorm watches, that's an enhanced risk SPC area. And we'll take a look at the radar shortly. And a winter weather advisory up there in New England. Yesterday was a busy day in the Midwest. I'm sure some of you were following that. We had a moderate risk for much of Iowa and down there in Arkansas as well. Fortunately, nothing like back on the 31st. We did have a few tornadoes, most of those in Illinois. 16 of those touched down and were confirmed, but numerous reports of hail from Chicago back to Des Moines, back to Kansas City, and into southwestern Missouri. And thankfully for Arkansas, that moderate risk did not pan out. So far for today, just a smattering of hail and wind reports. One little tornado touchdown around, I guess that's going to be around Fort Campbell, maybe just west of there. But there are a few tornado warnings out around Louisville. Yeah, right there in that area. Let's take a look at the radar. There's how things looked around Louisville around the time we started recording. This was 2054 UTC. You can see the Ohio River right there. There's the city of Louisville. And they did have a tornado warning out. This was a fairly solid squall line. So this looks like it was probably an attempt at a QLCS tornado. And that's it right there. We go to the velocity channel. Definitely some rotation in there, a little bit of convergence. Got to keep in mind the radar is right down here. So we're looking at it up to the north. And yeah, this right there, also a little bit of shear. and we roll that forward, and looks like that shear just kind of dissipated a little bit, and that's about where we're at right now. Well, a couple more frames, and looks like a lot of that circulation has washed out. However, it could always re-strengthen because we're heading into peak heating, and we've definitely got the sun doing its thing out there in the warm sector. There's how the cell looks at the current time. We get rid of all that clutter and even get rid of the warnings. You can kind of see that supercell shape. So this will have to be watched. It's going to be tracking south of Cincinnati and into southern Ohio. So not much going on. They did drop the tornado warnings, but still that warm sector is wide open. So depending on how things progress, it could strengthen or it could remain the same. Also, other cells down to the south, not doing a whole lot. We do have severe warnings on that. Let's bring up the Nashville radar. And of course, we can't really do a nowcast because it's going to take about an hour to an hour and a half to get this posted and all that. But anyway, it does have sort of a discrete appearance. You can see individual cells down the line, and because of that, that severe weather potential will continue at least for a couple of hours. And other discrete cells definitely showing up. This is getting into the higher tilts up near 10 to 20,000 feet up in the storm, but even that gives us good information. We can see that there are discrete appearances to the tops of the storms, so some of those could strengthen and become severe, although when we look at the SPC risk area, it does start tapering off into a slight risk. This will give you a general idea what's coming over the next 24 to 36 hours. We can definitely pick out that cold front. This is a plot of sea level pressure and 1,000 through 700 millibar thickness, so that kind of tells us where the fronts are. So that cold front all the way down to Mexico, and the warm front back into New York. And we can follow everything, including the squall line. And you can see all that freezing rain and sleet up there in Quebec and Ontario, but I don't think we have very many viewers up in that area. I think we have one viewer up in Alberta. If there's anybody in Canada, please post in the comments. I'm curious. So let's go up to about 10 p.m. Central, 11 p.m. Eastern. That's how things look. Some of the storm segments going into New York and Pennsylvania, approaching Pittsburgh, and other segments moving into eastern Tennessee. And that'll just kind of continue through the evening. Some of these cells down to the south, those are mostly forced, but they are continuing through the night. And then progressing into tomorrow, on Thursday, continued redevelopment down there in East Texas, down into the San Antonio, Austin area. Not looking for much in the way of severe with that. You can see that there is northerly flow feeding into those storms, so they are going to be somewhat elevated. The cold front down to the south, so these are back behind the front, and the front out there in the East Coast region, right through Washington, D.C., south of New York, and this is all cold air flowing into the back of that front. And that's being caused by this 1028 millibar high across the northern plains and another segment into the central Rockies. So a lot of high pressure, but as we get into Friday morning, some redevelopment, so probably some upper air energy starting to approach the frontal boundary offshore down there in Texas. And as we go into Saturday and Sunday, that area of precip just moves off into the southeastern U.S. Looks like there's just enough cold air and maybe evaporative cooling to produce a little bit of snow in the higher elevations of Virginia and North Carolina. At least that's what the NAM model is thinking. And we start getting a little bit of return flow out in West Texas, but this is a fairly dry and mild picture. So when is the next severe weather event going to take place? Well, you can follow along. We're looking at Dewpoints. You can follow the date at the bottom. And we get that northerly flow set in across the southeastern U.S., so that'll scour out the moisture. The oranges, those are going to be 60s Dewpoints, the yellows 50s, and the greens 40s. And we need 50s and 60s to get severe weather. So we're going to be drying out a little bit. The return flow starts to try to get established around Tuesday or Wednesday. 50s flowing up into the Great Plains all the way into Minnesota. However, not really seeing much forcing except up there in Nebraska. Depending on how this works out, there could be some upslope flow around Wednesday. Just looking at the generalized pattern here. And this is interesting, a little bit of low pressure out there in the eastern Gulf. And that's probably baroclinic. It has the look of a tropical system. However, I think that picked up that frontal boundary with that upper air energy coming in. As a result, development out there near Florida. So that's a little wild card that's thrown in. That will interfere a little bit with the return flow. You can see it pulling away some moisture to the east there, and that has an effect on the moisture coming into the Great Plains. So that'll be a factor later next week. But overall, I think we are heading into kind of a quiet period, except maybe up there in the Central Plains. And before we close out, let's take a look at the satellite imagery. College of DuPage, that's a great website to get satellite data from. That's going to be at weather.cod.edu. And what I'm going to do is I'm going to show you the different channels. You can see these ABI bands out here on the left. Those are the 16 different channels offered by the GOES series, and that started flowing about 2017. Before that, we only had a very limited number of channels, and this gives us great detail as far as the spectral bands. Now, what we have here on the left, you can see channel 1, channel 2, channel 3, all the way down to 16. These are in order of increasing wavelength. So your shortwave channels are up here in the top left, visible, blue, red, near infrared, and that goes all the way to the long wave infrared down here in the bottom. So let me just show you very quickly. Channel 1, that's going to be the blue image. We don't really use this a whole lot. However, it's very sensitive to dust and smoke. So you can definitely use it for that. Out there in the White Sands area, the dust plume that we had yesterday, that really showed up well. Let me see if I can pull that up. Yeah, you see that? That's that plume. And this is the best channel that showed that plume. So you can use that to find dust on these images. So back to today's imagery. Channel 2, right here, that's red. And that is the traditional channel used for visible imagery. Veggie, channel 3, that's used to pick up some of the signatures from vegetation. It's very sensitive to leaves, grass, foliage, that kind of thing, and it will show up rather bright, and that does appear to be the case in the southeastern U.S. and the Great Plains area. However, some strong returns in the southwestern U.S. from the hot terrain. Okay, I moved the image over a little bit, so now you can see the numbers on the left. So sorry about that. Channel 4, this is the Cirrus channel, and indeed it's very sensitive to Cirrus. You can pick out that cloud shield, the MCS, the anvil tops, also the subtropical cirrus out there in West Texas, and also the shallow convection with the glaciated tops in the Rockies. And you notice that we don't really see any low cloud here. Channel 5, snow and ice. That's useful for differentiating snow and ice. See that patch right there in South Dakota? Let's zoom in on that. And you can see that dark smudge right there in east central South Dakota, and not very much to the north. Let's take a look at the true color. And you'll notice that all of this is snow cover because it's not moving. And we've also got some sort of snow or ice on the ground out here, which is not moving either. So what you're actually seeing here is some of that freezing rain, which has created ice on the ground, and it's creating that smudge that we see right there. If we run back the surface charts, see, we go back to yesterday evening, there's that snow up to the north, and keep an eye on these plots right around here, and you can see freezing rain at Huron, and freezing rain also there at, I think that's Watertown. Yeah, Watertown. Okay, so that's what you're seeing. So, very useful. Particle size, let me go back to the continental image. That differentiates small particles, which are bright, and large particles, which are dark. Now, I'm not sure I see any good examples here. I can definitely see that ice on the ground right there, because there is some overlap with channel 5. However, I've not really used this product very much, so I'm not really sure if I can pass on any words of wisdom about it. As we go up to channel 7, we get into the shortwave infrared, and as we bring up channel 8, that's where we start getting into the water vapor imagery. Now, channel 8 here, that's your upper level water vapor imagery. It's very sensitive to 20,000 to 30,000 feet up. So we're talking about the upper levels of the troposphere. So definitely picking up that MCS there. And looks like some dry air coming into the back of that system. That's part of the dry slot out there in Missouri. Mid-level water vapor, that's sensitive to about 10,000 to 20,000. And we can see that dry slot a little bit better right here. And channel 10, that's the low-level water vapor imagery, and that's sensitive to a slightly lower layer, about 8,000 up to 18,000 feet. Very subtle differences, but this does reflect the drier mid-levels of the atmosphere flowing into the back of the system and underneath that anvil canopy. ABI channel 11, cloud top phase. We don't really use that much in meteorology. That's mostly used for volcano monitoring. Same with channel 12, ozone. It's supposed to be sensitive to ozone, but we don't really do much atmospheric chemistry here on Forecast Lab. Now we get into the interesting products. Channel 13, that's the clean long-wave infrared. That's the traditional infrared imagery. So this is what you use when you're forecasting. This is available 24 hours a day. So we can see the squall line, you can see the colder tops, the stronger energy, the higher echo tops right there in Louisiana into East Texas, and this shows that the strongest cell is up there near Cincinnati. It's probably sheared over a little bit, but this also tells us that there's not any indication of very strong cells in Kentucky or further north up there in Ohio. Channel 14, those are very similar to channel 13. As we go into those higher channels, there's more attenuation from atmospheric moisture. So this is going to look very similar, same with channel 15, but more and more interference from atmospheric moisture. So not quite as good. Maybe a cloudy texture up here in the north central U.S. Compare that with channel 13, and probably a little bit more contrast. So that's just something to keep in mind there. And channel 16, we don't really use that at all. That's atmospheric chemistry again, and that's mostly used by automated processes. And of course, there's also the multispectral products down here below. I'm not going to really cover that into too much detail, but some interesting ones to look at. Nighttime, I love this NT Microphysics. Can't use it during the day, but at nighttime, fog and stratus will really stand out, as long as there's no higher clouds. Also the Airmass, that's kind of interesting. It kind of differentiates different areas of moisture and temperature. And true color, of course. We use that a lot here because this is not really a true color image. It combines the red and blue with the Veggie channel. So the green that you're seeing here is actually from the Veggie channel, near infrared. So it's not really true green. But it gives us a close enough estimate to what we would see if we were up there in space. And we're coming up on the dreaded 6 p.m., so I need to get this wrapped up and uploaded. Many thanks to our supporters, people like Harvey Chevalier Jr., Kelly Miller, Travis Munn, Caleb Weaver, Michael O'Neill, David Fick, Rebecca Marks. Thanks to all of you for helping to keep this program going. That means a lot to me, and it helps motivate me to keep putting out these episodes and adding content like what we had this afternoon. Hope you have a great Wednesday evening, and we'll see you back here on Friday. Take care. Bye-bye.